Hey guys, welcome to example 7 of 6.6, and we are looking for nth roots. We have a formula here, and it looks kind of complex, and truth be told, I'm going to show you in a way where it's super easy, but this formula is the same thing that I'm going to show you. The numbers are the same, it's just I'm going to do it in degrees, or radians actually, but degrees are actually way easier in this case. And again, the math will be the same. It's just if you want to follow a formula, you can use theirs. And I'll go over how the formula works as well by looking over their notes. But I'll show you how to do it by hand with degrees, and it's super easy. So one really important thing let's go over the basics of finding the nth roots of a complex number. Think about taking the cube root of 1,000. You would have 10, and if you cube 10, then you'd get 1,000. So that's how you know you've done a cube root, right? The thing about the roots of a complex number is because since we look at it in polar form, we understand that with angles and trigonometry, there's more than one way to get the same value. And so the first thing we want to do is identify what n is. Because if we're looking for the nth root, in example 7, it's the fourth root. That means n is equal to 4. Right? Fourth root implies n is equal to 4. Now, what does that mean? That means that there's 4 distinct answers. That means there are 4 separate polar complex numbers that are the same number, but in polar form, there's different angles to get you the same number. And when you multiply those by themselves, right, you're going to get a z1, z2, z3, z4. When you do z1 to the fourth power, or z2 to the second power, z4 to the fourth power, they will all get you z, right? They'll all get you 5 cosine pi over 3 plus I sine pi over 3. So there are 4 answers. And the key thing to understand is the starting angle and the angle measure separating the roots. And it's really simple to see. So the starting angle, we know theta is pi over 3, right? So I know in this case, theta is equal to pi over 3, or in this case, 60 degrees. And so we want to then take theta and divide that by 4, okay? So that means our first root, our first angle would be theta over 4, which means that it's going to equal 15, right? So 60 over 4 is 15 degrees. That is our first angle. And from our first angle, we also want to know how many degrees apart are they. And so all we have to do is, because we're looking at, the complex plane, the angle going all the way around is 360. So one thing you need to understand is that each one of the roots, they're all separated by the same amount of degrees or radians, which means that if you're 15 degrees, that's why I have these orange lines, right? 1, 2, 3, 4. Okay. If this is 15 degrees, then that means the other ones would have to go this way, and this way for them to be evenly spaced apart. Well, how do I figure out from here to here? Well, that's just 360 divided by 4. So, let's see, angle measure separation, in this case would be 360 over n, or in this case, 360 over 4, which is 90 degrees. Okay, so I know that each solution will be 90 degrees apart from each other. And the last thing I need to know is the radius of the nth roots. And that part's easy, because if you do something multiplied by itself 4 times to get 5, well, that's just the fourth root of 5. So you know r is equal to the fourth root of 5. That part I don't think I need to explain too much about, because you know that repeated multiplication just means of complex numbers, just means repeated multiplication of the r. And so if you have fourth root of 5 times fourth root of 5 times fourth root of 5 times fourth root of 5, or fourth root of 5 raised to the fourth, you get 5. So you know the radius has to be root 5. So let's write z1. Z1 would have a radius of fourth root of 5, and it would be in the angle direction cosine of 15 degrees plus I sine of 15 degrees. If you want this in radii form, or radian form, you could just say it's pi over 3 divided by 4. Pi over 3 divided by 4 is pi over 12. So then that would be cosine of pi over 12, I sine of pi over 12. And again, if you needed to figure this exact value out, or this approximate value out, you can just put this in your calculator, right? Or use a half angle theorem or something like that, or double angle theorem. But at the end of the day, that's going to get you your first fourth root. I'm going to save the next part for another video, because maybe I'll make a mistake, and editing these things is kind of a pain with my slow computer here.